Okay, so this is going to be the first video of Chapter 5, and so we're going to do Chapter 5, and we're going to introduce in this chapter what I feel is the most important concept in physics, and that basically all the time when you're talking about physics, you're basically talking about one concept time and time and time again, and that concept is energy. And pretty much every sort of discussion you have, you can sort of tie it back somehow to energy. And now there's all kinds of different aspects of energy. Obviously, if it's one of the most central concepts in physics, it's going to have a lot of sub-concepts coming off of it. But we are going to talk about three of them today. We're going to talk about work, kinetic energy, and gravitational potential energy. Okay, now out of these, this one has the word energy in it, kinetic energy. This one in here, gravitational potential energy, has the word energy in it. And our overriding concept is energy, and so people have not much trouble tying these two into this concept of energy. This one does not have the word energy into it. So I found that time and time again, people don't understand that work is a form of energy. So when we're talking about work, we're talking about energy. Remember that, remember that, remember that. Okay, so we're going to spin off three equations. Work equals force times distance. We're going to have kinetic energy equals 1/2 mass times velocity squared. And we're going to have gravitational potential energy. We're going to call that GPE is going to be equal to m, the mass, times the acceleration due to gravity, times the height. Now this equation, so now there's notes on all those equations, and I'm going to just jump right in with one here. This version is only valid Okay, this version, this equation, G equals mgh, or GPE equals mgh, that's only valid near the surface of the Earth because of this right here, this G, that negative 9.81 meters per second squared, that's only true near the surface of the Earth. So we'll later on we'll introduce an equation that will allow us to figure out gravitational potential energy at any point in the universe, but for now, for this simplification, we're going to stick to this equation, understanding that most of the time we are near the surface of the Earth. Okay, so let's go define some terms. That's force. And remember, its units are newtons, which we're also going to call kilogram meters per second squared. And then we have d, which is going to be distance, and that's going to be meters, which is m. we're going to have m, which is mass, and the units on that are going to be kilograms, which are going to be kg. We're going to have v, which is velocity. That's going to be in meters per second. And then we are going to have, I'm going to throw height onto there. Height is also a distance. Let's just call it height. And that's also going to be meters. And then we're going to have g, which is acceleration due to gravity, Earth's gravity. And so that's going to be negative 9.81, and the units are going to be meters per second squared. Okay, so there's our terms. So if I'm looking at just units, I want to look at just units over here. So I have work equals force times distance, and that's going to be newtons times meters, or it's going to be, if I use what a newton is, it's going to be a kilogram meter per second squared times meters. So it's going to be kilogram meter squared per second squared. Now if I've got KE equals 1/2 mv squared, if I look at just the units, I'm going to have the 1/2 does not have any units. The m has units of kilograms. The v has units of meters per second. And we're going to square that, so we're going to get kilogram meter squared per second squared. And then finally, we're going to have GPE is going to equal mgh. The units on m is going to be kilograms. Units on g are going to be meters per second squared. Units on h are going to be meters. And so we're going to get kilogram meters squared per second squared. Okay, so work, kinetic energy, and gravitational potential energy all have this term kilogram meter squared per second squared. And so we're going to give that a special name, because we don't want to say kilogram meter squared per second squared before. So previously, just using this little sheet of paper up here, we said a newton was a kilogram meter per second squared. Now we're going to say the joule is going to be a kilogram meter squared per second squared. So when we have kilogram meter squared per second squared, we're going to call that a joule. Okay, so I think that's where I'm going to leave that right there.